Hello and welcome to the first VMK in the physics series. In this introductory video, I'm not going to be showing you how to make anything. However, what I will do is sort of give you an outline of what my plans are in this physics series. What we're going to do is we're going to take the game engine, which I just finished developing earlier, and you can pull those videos from the game engine series. So what we're going to do is we're going to take this game engine that was developed here, and we're going to add a physics engine component to it. If you've gone through these videos, you already know what is involved to load 3D models, how to move them around on the screen, how to handle textures, how to handle lights, and things like that. Anything that happens inside of the 3D world, you will notice that you had to calculate by hand and cause those objects to move based on your calculation. Now, what we're going to do with the physics engine is we're going to get it to calculate everything for us so that we can say, here's an object, apply gravity to it, and tell me how it should behave. Or, here's a car, I'm applying the accelerator in the car to move it forward, calculate for me exactly how the car is going to react as it's hitting objects, as it's going over ramps, things like that. That's the responsibility of the physics engine. The game engine, or the graphics engine, is responsible for rendering the results. The physics engine is responsible for calculating what's going to happen as the simulation or the game is running. So the physics engine is going to be heavy on mathematics because that's basically all it does. Calculates different kinds of motions, different kinds of forces, different kinds of torques. A lot of vector math is going to be involved. I'm going to be going step by step explaining how all these pieces fit together so that the physics engine and the graphics engine can communicate to one another and the game can run in real time. We're going to be continuing off with the code that we developed inside of the game engine series. However, I've made a few modifications to the core. Instead of working in Visual Studio .NET 2003, I've migrated the game engine series code to now be using the Visual Studio 2005 compiler. At the very end of the game engine series, if you purchase the DVD, you'll notice that there's one VMK number 45, which shows you how to convert this code to be 2005 compatible. There's a few things that should be cleaned up for you to make this transition. I've decided that it would be a little bit of a hassle to ask everyone to go in and complete the game engine series VMKs before they can start the physics engine. So what I'm going to do is place in the store an item which you can go ahead and purchase, and it's going to contain all the source code for the game engine up to and including VMK number 45. So what I've done is I've taken all this code, cleaned it all up, converted it all to Visual Studio 2005, and that is going to be our starting point for the physics engine. If you don't want to use the game engine when working inside of the physics series, that's fine as well. You can still pull from the physics series very useful information for how to do calculations for different kinds of physical effects. So don't think that you need to have the game engine to complete the physics series. However, I will be building directly off of this game engine, which means I won't be going into the details of how to render items onto the screen or how to create certain items that we've already covered in here. If there is something new that I need that the game engine currently doesn't have, I'll go in and add it. But for the most part, we'll be just building directly off of this game engine here. So once again, if you've already completed the game engine series here, you're going to be in great shape to continue on with the physics engine. If you want to start directly inside of the physics engine series without this game engine, you will need to have your own graphics renderer implemented so you will have a framework to work inside of. So enough about that. One other thing before I finish off this VMK is if you have a specific request for the physics engine, please send me an email so that I can incorporate it into a video. I'm going to start off by covering simple physics like gravity, wind, directional forces, and then I'll be going into more detailed things like torques and rotations. We'll then progress on to more complex things like collision detection and collision response. If you have a certain game in mind that requires physics, but it's a topic that you're not quite sure about, send me an email and I'll write it down on my to-do list to make sure I add it into the physics engine series. Alright, I think that's about it for this VMK, and I hope to see you in VMK number 1 of the physics engine.